going to skip, go to 19. An astronaut has a spacewalk, a distance r above the Earth, Earth's surface. So let's take a look at this picture. Again, here's another time where they say the r is it's an r distance above the Earth's surface. So we're going from a distance of r, we're on the Earth, to 2r. We're doubling the distance. Double gets squared. There's no change on the top, so this is an inverse square relationship, so it's g over 4. When this doesn't change, we'll call it a 1. Nothing here changes, so it's 1 over 4. 21, you're at a distance of 1,400 kilometers from the center of an Earth. Its g is 32. 2, what's the g at 28? What are you doing? You're doubling the r. So let's do it again. There's nothing on the top that's... We need an equation. We're asked for the g, so this is the equation that gives us g. We cross out the little m, the orbiting mass, leave the big M, the mass that's being orbited, and we see g equals big G, the gravitational constant m, over r squared. There's an inverse relationship, inverse square, so double is 2, 2 squared is 4, no change in the top, 1/4. 1/4 of what? 1/4 of the original, making it 16. And I think, oops, no, we're going to go to 27. We're going to skip all the way to 27. 2 satellites the same height. Orbital velocity of x is v. What's the orbital velocity of? Well, let's take a look. What orbital velocity is v? It's this. We use this equation because it relates v and r. The centripetal force is gravity, so mv squared over r is the gravity equation. Cross out the smaller m, and cross out one of the v's here, and then make this a 1. So then you get this equation, and you say, well, if this doesn't change, this is the same, so the v is the same, and that's why it's that answer there. And 29. Student weighs 500 newtons, that's the force of gravity, travels to a planet whose mass and radius are twice the Earth. So let's get the force of gravity equation that will determine his weight. Double the top and double the bottom, because that's the mass is doubled. They're saying 2m and 2r. So double the top because the m doubles. Double the bottom, that's double squared. 2 over 4 is a half, so it went from 500 to 250, half. 31. A mass m moves in a circular orbit r with a radius v. What must be true? What equation has all those things? This one over here. Okay, and this is also true, that the weight is the force of gravity. We can cross out the m's. Let's see, 3. The orbital velocity is... wait a second. Number 3, okay. Why is the orbital velocity this? Because this is right, so the little m cancels out. This is supposed to be r squared. And this r cancels out, and it makes this one 1. So we see v squared equals radical, v squared equals gm, the gravitational constant, m over r squared. And then you take the v is the square root of gm over, this shouldn't be r squared because one of the r's canceled out. So it should be that. That is this answer over here. 1 is wrong because it's not mr over v squared. It's mv squared over r. The acceleration is gm over r. No, the acceleration is gm over r squared. Planet's mass can be determined by the orbital. It could be determined if it's orbited by a small satellite by equating the gravitational and the centripetal acceleration, which below is not required. So since they're talking about g, I'm going to pull out this equation. Look, the small m, the mass of the satellite. Oh, what's canceled out always on both sides, remember, it's not the larger body, but the smaller body that's circling around the larger body. Mass cancels out, so it doesn't matter. 35. Planets have the same surface gravity, but 2 planets have the same surface gravity, but x is twice the mass of y. Planet X has a radius of r. Oh, I think this one's a nice one. This one's a real challenge. So this is a question about surface gravity. So this is obviously, that's little g. This is obviously the equation. So we solve for little g and we get this. Let's see how this works out. So two planets have the same surface gravity. So their g's are the same. So gm over r squared equals the other planet, gm over r squared. These are the same, g. So it's m over r squared equals m over r squared. So two planets have the same surface gravity, but x and y, x has twice the mass, so 2. And planet X has a radius of r. What is the radius of y? So that's over here. We'll call this y, so this we'll call it ry. This is 2m, and it got a little sloppy. 2m cross multiply. 2m times ry squared equals mr squared. This one has a radius of r. M's cancel out. Let's see, so 2, I need a little room, but I'm going to go up here. 2 radius of y squared equals the radius of x squared. Actually, yeah. So we'll just call it r. X is we'll just call r. We'll divide both sides by 2. So ry squared equals 0.5 r squared. Take the square root of both sides. The square root of 0.5 is 0.707, which is the answer right here. There's another real winner, huh? And I think we'll do one more and that'll be it. The surface gravity on the Earth's moon is 1/6 of the Earth. The moon's radius is about 1/4 the Earth's. What is the mass? Okay, let's do this one over here. Let me clean this up. I think this is a real winner. So the surface gravity is g. So I'm going to quickly use this one over here because it relates g to r. The little m cancels out, and g depends on the gravitational constant, the orbiting body, r squared. Surface gravity on the Earth's moon is 1/6 the value on the Earth, 1/6. The radius is 1/4. The radius is 1/4, but that gets squared to become 1/16. So 1/6 g. Now everything that stays the same can go away. So m does change. This is what we want to find. Divided by, so if 1/16 is on the bottom, which it is, I'm running out of room over here. Oh, that helps. M 1/16 r, because 1/4 squared. So 1/16 on the bottom. We can multiply top and bottom by 16, and we get 1/6 g equals 16 m. Divide both sides by 16. Let's fix that, 1/6 g. And you get 1/96. And that's that answer there. Just to recap, they talked about surface gravity, so I have no choice but to use this. Cross out the little m. 1/6 g is what we're told. 1/4 of the m. What's the mass of the moon? So 1/6. So the 1/4 gets squared, because the r is squared. You get 1/16. Multiply top and bottom by 16. And you'll get that. Divide both sides by 16. 16 times 6 is 96, and that is it.